we've got a probability question here, and we've got a couple of parts to it that we've got to work out. So it says a student exercises on Monday, Tuesday and Wednesday each week. On the Monday, they always choose between cycling, running or swimming. Then they choose one of three types of exercise on the other 2 days, except that they never do the same type of exercise on 2 consecutive days. So this is important. They never do the same type of exercise on 2 consecutive days. So if they're done running, they're not going to follow it with another day of running. And they always follow running with swimming. So this is another constraint here. They always follow running with swimming. Running with a swimming day. Okay, so it says draw a tree diagram. So on the first day, they can do anything. They can do, between cycling, running and swimming. Now, there's a constraint here, because if they've done cycling, they're not going to do cycling again, so it only leaves running or swimming. Okay, so this is Monday. On Tuesday, if they've done cycling, they could do running or swimming. If they do running, they will always do swimming. So they always follow a running day with a swimming day. So this is, if they did the running on the Monday, they're going to do swimming. They're only going to do one thing. And if they've done swimming, they're not going to do swimming again, but they could do cycling or running. Okay? Now, one of the constraints there was every time they ran, they always swam. So on the Wednesday, they might swim. Okay? Or if they run, they have to swim. Okay, so I put those 2 in. And now if they've swam, if I go to this one, they might run or cycle. And if they've swam, they might run or cycle. If they've cycled, they might swim or run. Okay, because they're not going to do anything. So our choices are going to become CRS. So I'm following down here. CRS could be one of the options. So I'm following down the trees. CSR, cycling, swimming and running. CSC, cycling, swimming, and then cycling. Take my time and do this properly. Running, cycling and running. Running, swimming and cycling. Running, swimming and cycling. Swimming, cycling and swimming. SCS, SCR. Or SRS. Now it's always good to write these out. So there's 1, 2, 3, 4, 5, 6, 7, 8 possible different combinations of what they could do. Alright? So hopefully have a look at this again if you need to, but there should be 8 different combinations, and the couple of constraints that you had to really take note of, which I underlined before. Now, so that's drawing the tree diagram, and then you should list out what the, that's called your sample space, so what could possibly happen. Now, for B, we start doing some probabilities. So let's just have a look at B. If each outcome of the sample space is equally likely, what is the probability that the student swims on a Wednesday? So that was Monday. I'll put it over here. That was Monday. That was Tuesday. And that was Wednesday. Okay? So swimming on a Wednesday meant that there had to be an S. They swam on the last day there, they swam on the last day there, and they swam on the last day there. So the probability of, for number 1, swimming on a Wednesday equals 3 out of a total of 8 possibilities. For number 2 here, it says does not run at all during the 3 days. So is there any ones that didn't have an R in them for running? Well, that didn't. There's twice there, there's once here, there's none there, and that's 2 out of 8. So the probability of not running equals 2 out of 8, or 1/4. Okay. For 3, we're looking swims on one day and then cycles on the next. Probability of swimming, then cycling equals probability of S then C. So we're looking for S then C, swimming on one day and cycling on another. We're looking along here, S first and then C. Well, there's an S and a C there in that order. Actually, back here there was an S and a C in that order. There is an S and a C here, an S, then a C, and I think that was it, 1, 2, 3, 4. So 4 out of 8 possibilities, which equals 1/2 of swimming then cycling. And the probability of runs on 2 days, for 4, probability of running on 2 days equals. So running on 2 days, I'm going to clear this off. We're looking for anything that's got 2 R's in it. Run on a run is only 1 time out of the 8, so 1 out of 8 is the probability of running on 2 days. So the important thing is to really get your tree diagram correct, list out these sample space so you can see easily what the different outcomes are, and then you can answer the probability questions.